Hello, I'm Brian Gleason. I'm a Mastercam applications expert for MLC CAD systems out of the Arizona office. Today I want to talk about CIMCO probing and machine automation. So what is automation for manufacturing? So quick question, what are some examples of automation? So some of the more common examples would be a robotic loading system, so using a robotic arm to load and unload parts from the machine. Other examples could be a pallet system, so you have a pallet pool or linear pallet system, something that's going to be loading pallets in and out. More examples would be lights out machining, so doing as much as you can unmanned overnight. And then lastly, making sure that we're controlling the accuracy on the side on the machine itself. So maybe we have to hold tight tolerances that are being machined, and we want to make sure that those are being held. So how can CIMCO probing assist in this automation project? Well, we can use it to locate parts and help set work offsets, measure features and update the machine accordingly using logic, or we can output feature sizes for documentation. So using a touch probe on the machine is nothing new. People have been doing it for a long time, and just ways we've had to do it in the past are a little more time consuming, you might say. So hand editing might be one way you were doing it. You might take a posted program, you insert all the codes that you need, you might have to have them memorized, you might have a copy and paste, all the ones that you would be using on a regular basis. Very similar to that would be manual entries inside of Mastercam. So along the same lines, this time we're just doing it inside of a Mastercam program. It would be saved with the program. It'd still be hand editing. You'd still be typing it in or copy and pasting it into the program itself, still leaving room for error. And then lastly, another common way would be using the MDI or whatever VKQC. Sorry about that. Being able to manually input it on the side of the machine using the interface itself. So, what about manual edits? It's going to take intimate knowledge of the actual cycles themselves. So going through the manual, figuring out what the exact values mean, what they need to be, what they're going to be able to do. Manual is also going to leave more room for human error. So if I accidentally fat finger a 1 somewhere, that's going to mess up measuring distance. Not able to prove it out before hitting the machine. So not able to go make sure that it runs through a simulation or a backplot or something like that, and seeing it actually going where I want it to go. So taking that chance of crashing it on the machine. Programming on the machine, well, if the spindle isn't moving, so it's not making chips, it's not making money. So what do we have for a solution? CIMCO probing for Mastercam. So let's look at some of the features of this. It's got a pretty intuitive interface. You're visually informative, provides the ability to simulate. So you get a lot of benefit from that, being able to run through there and actually see where the probe's going versus your stock, any material, making sure that you're not going to go and crash inside of the machine or break another stylus. So we got here is I have a couple parts. So the idea is this: that we're going to be having a robot arm load the first operation, and then it would be also progressing the part over to the secondary vise for the second operation. So it's already programmed. We already got our staging for the stock model, so we can see what's going on. But we need to add the probing routines. So to get that going, let me make sure that my insert arrow is up on the first one, and we have our work offset is set. I can see op 1, op 1, op 1. So With the CIMCO Probing item, there's going to come in with another context menu tab, and then inside of there you'll have all the probing cycles. So this one we're using a Haas machine, so it already has the Haas run the shop programs. And the first one we'll start off will be outside corner. First thing first, need a tool. So I'll go into the tool manager, we'll select a tool, I'll go into the filters, make sure we're using lollipops, and we have our probing tool. I'll bring it in. On this machine, the tool number is 31. Have it. So we have a tool, we'll go into our cycle. So we're going to do an outside corner. I'll select the lines. And I'm going to shift my spacing to make sure it stays on the part. It's looking at the overall length at the moment. And I'll drop down. So some of my favorite numbers inside there, just to make sure we're measuring. And we're going to be having a safety distance. We'll set G54. So there's our first work offset. I'm in backplot, where we can run through the cycle and make sure that it is going to look correct and not run into anything. Next, I want to set the Z height off the stock. And if we did a quick analyze, look at this, we can see that Z is actually 25 thousandths above Z0. So we'll go into our probing cycles, workpiece datum. And when I said it was an intuitive interface, you can see that it is going to bring up the cycle plus give you a little information about what is going on. It's going to look real similar to that Inspection Plus manual for this. So we're doing point 1 axis, tool, cycle. I'll go up here, select the point. I'm just picking a random point. Basically, it's the center line of that counterbore. When we start off, there's going to be material there. So let's give it a clearance height and a little bit of safety. So if I'm touching off the top of the stock, it's going to set that as Z0. I need to shift that, so we'll add a shift of minus 125. Cool. So now we have G54 is going to be set XYZ0. Now we're going to add some extra logic before we get too far off there. So using the probing again, I'm going to do a workpiece inspection. This time I'm going to do diameter inside 4 points. We'll use the same tool, cycle, and right click, select arcs. We'll come to the graphics view. I'll select that bore. We're going to pretend that this is a plus minus 1 bore. So I'll set my height. We'll go a little bit deep and set a safety height. So get a nice little preview of what's going on. Now, using that information, we can always output the nominal diameter. We can say what work variable that we want to use, and if need to, we can deprint this out. And if we need to have a report, so maybe we come in the morning after this was running all night and I can see, all right, this part was out. Well, we'll use some other logic for that as well. So if I'm here, I'm going to measure things. We can add some if-then logics to it. So if it is scrap being oversized, I'll do a manual entry. I'll type pound 3000 equals 1, and part is scrap. So this will put the machine in alarm state and give you that message. Remachining, I'll say we'll go to an operation. I'll find the first, it was the C board that was actually cutting through there. And then if it is within tolerance, it will just continue on. You could set it to a go-to, but you do have plenty of options. You can have it stop, you can have it go to a group, go to an operation, program end, or do another manual entry. Using the tool data, I'm going to set a greater than, less than. So like I said, we're going to do 1000s. If it's undersized, I would like it to update the machine, so we'd be able to update the control to say, hey, we need to comp this out, and then it will go back, rerun, and then rerun the cycle, rerun the probing cycle, make sure that it's good. We can say, what is my adjustment? So maybe I don't want to creep in on it, so I'll only do 50% of the feedback, and from there, I'm pretty good on that. Alright, lastly, we need to set our G55. So I'm going to go to my planes, make sure that my position is set. We'll go into the toolpath group op2. I'll add a probing cycle. We'll do datum, and we'll do another diameter inside. Tool, we'll go to our cycle page. On this one, we'll select the arcs. We'll measure the inside arc. Let's see, I'm going to give it a measuring height, minus 0.125 clearance height. So I have 200 thousandths on the bottom. I'm going to probably add quite a bit of clearance, and then we're going to set G55. So you have all the different offsets available. So, and looking good from there. Green check. Now we have all the probing cycles done. Let's see what, I'm going to just prove out what the probing cycles look like. So I'll select the stock models I have for both operations. I'll select the probing. So measuring. So we're doing outside corner, back left. Then it'll come down, touch off the top. Now we'll come over and set our G55. Lastly, I'll go ahead and post out operation 1. Let's make sure I have them all selected, and then we'll put them out. So we'll have it open up in our Code Expert. We'll give it a quick look and see what all is inside of there. So you have the tool call, you have your safety heights, you have your on, you'll have your safety protected moves, and then your actual probing cycle protected moves. And then we'll look at the touching off of the top, and we'll set G54, and then we'll do a work shift for G54. Once we get into the actual machining cycles, I'm going to go ahead and skip and look for an if. We're able to get it to come out, and we already doing our probing cycles, and then we have our if then logic statements. They're going to correct the machine if that part's oversized. Cool. And then if we want to do the second operation, we'll see that it will be probing, setting the location. So why is this important? Just kind of double check, make sure that the robot is placing exactly where it needs to go. That way we are going to flip the part over, move it out into position. They're going to be a lot more accurate because we're double checking with our probe and make sure it's all located correctly. So, and going on from there, what are the benefits of this? It's saved with the Mastercam file. If we have to repost everything, it's going to be there. It's an intuitive interface. It's going to be liked by a novice user to be able to see more information of what's going to be happening, and I'm sure it'll be appreciated by some of the veteran programmers as well, to be able to that do have that intimate knowledge with the probing cycles. It's visually informative, so you get a nice little preview of what the actual functions are going to go, and plus we're able to simulate it on the machine, well, not on the machine, in Mastercam or in a machine simulation prior to it hitting the machine, to make sure that it's not going to end up breaking a stylus or something else is going on wrong with it. So hopefully that helps you with your next automation project. If you do have any more questions, feel free to always email us, call us, or reach us out on our social media outlets. Thank you.